Today we are going to calculate some accuracies and the functionality on the MNist datasets. These MNist datasets are provided from the different sources. Now we are using this Keras. We are using from Keras library, which is further available in TensorFlow. So this dataset has been provided to us as per our professor and as per our assignment section. So here I have loaded the data sets, and actually today I'm going to deal with three different kinds of algorithm to handle these data sets. So for this I have loaded these data sets here, and as per our provided assignment, this is for the checking values whether the data sets are provided, how the data sets are. So the data sets has 60,000 training sets value and 10,000 testing set values with 28 by 28 shape. It has been provided to us. So we just plotted one data values to show that how it looked likes in the vector form, and it has converted its value in the vector form as per the RGB color mode, which is from 0 to 255 values, and 0 shows as the dark and 255 shows as the white value. So it has been placed as per like that. So here it has been shown as the color format, and we are here to normalize the data. We have done normalization of our data dividing by the 255 value, so that the value will be in the 0 to 1 form, and it will be for more easy for us to for the calculations. So now as we are using the dense neural network module, here input shape is defined for universal 28 by 28 in flattened form, so that the matrix is going to convert it in column matrix. So I have given all details. Here's the dense model. Here define that the fully connected model, which is one neuron, will take input from each and every input. So we have defined the layers in neurons, which will flatten the image in 28 by 28, and the as per the input shape. And yeah, the as per the neuron values, the neurons, which is composed of input, output, and the input hidden layers, and those hidden layers are densely connected with each others. So we have shown that we have used those values here. And for the activation function, we have taken ReLU functions, and for the dense of this 10, we have taken the softmax also. And now here we are compiling our model, where we are designing our model here, and we are compiling our model here with the optimizer Adam and loss with sparse category trophy with the matrix of accuracy. After that, we stored our model to fit in a object of in history for further calculations, where the model performed like this way, and we obtained this value as 0.99. It means 99 percentage with the values of the classification of the values. And we try to look the epochs and the accuracy epochs and the losses of these things. So how much our algorithm is going to work, how much our algorithm, what is the performance of our algorithm, and we try to plot it out. We can easily view these things here. So I calculated it for the further evaluation also. So it has given the prediction evaluation value of the our DNN model, which is dense neural network model. And yes, so it has yes accuracy of 98.08, 98.07. Yeah, and we have taken the other value, the other, I mean other algorithm for the further calculation. This is the CNN. the convolutional neural network. Convolutional neural network is composed of it is also composed of the combination of input and output, where the input values will be of multiple types, and the inside dense layer will be also of multiple layers, which will flatten the image, and it will flatten the same image into different portion and different layers, and it will take it for the further calculation to for classify the things. So every neuron will be connected with other two for the calculation and the classifications. um, Here we define our training values and testing values, and the shape of the our training values, we reshaped it in the 28 by 28 into one also. And here we are here we are hot encoding our module with the neural network uh, uh, hot encoding module systems. Here we are defining our convolutional neural network modules. So where we have called the convolutional neural modules from the Keras layers, and with it has also the activation values of activation function of ReLU. And here we have defined our kernel size of 3 by 3, and input shape it is same 28 by 28. Further, we have chosen the dropout value of 0.25, and our image has been also, our layers has been, I mean layer flatten is very important here, because it is going to calculate same image for different portions, so it will flatten this portions. And we have defined the dense as here for the dense section we have taken 128 values, and activation of this neural network ReLU. Again, dropout is 0.5, and yes, we have taken here softmax for the activations, and we let it for the further calculations by the compiling models, and with optimized ADOM and accuracy. Instead of Atom, I have tried with the Adelaide here, but while I tried with the Adelaide, the performance was not good and it took a lot of time. So I found Adam is the best. I also prefer this Adam, because before this Adam, I had tried with the Adelaide or something like that. It wasn't found from the resources, and I looked it. So I found it the best, and yes, we have here the highest value before than the dense neural network. So convolutional neural network has given us the good values here, and this is the loss values, and this is the accuracy values. We also try to plot these values here in the here in the graph, and from the graph we can see this is the value. Similarly, I further begin with another module. This is the another algo of with the sigmoid functions having or logistic regression values, or classification modules, which will take the sigmoid function for the further calculation. So it is also normal neural networks. Here again we have taken the values for the normalizations, and again we have reshaped our model in the 28 by 28 again as per the length, and we define our module here with the same things, but here we for the activation module we defined our sigmoid functions, so that the every values will be inside the 0 and the 1, and we can have the classification section from here. And for the optimizer, again I have chosen here add-on, and this is for just the testing purpose, if my model is working or not, because I have to convert my image into this 784 6000 into 784 these portions. That's why. So I have set my object in history 3 portion here to get these values in further calculations, because I need the data to look which algo is fine. So I the for the logistics section, I defined it as the LNN, and I evaluated like this, and here is the prediction value of the here is the accuracy value of the algorithm, and I try to plot this in graph, and by this way I can get this result of the losses and accuracy. Further, I try to plot this all these three algo. What I figured out from these three algo is, so while checking on those three algo, here this CNN has the lowest loss, and it has highest accuracy. After that, this dense neural network has the a little bit higher than the CNN, and in the loss section, and the accuracy is also a little bit low than the CNN, while this segment values has given me the highest loss among all those three, and the lowest accuracy for the calculation values all among these. So by this way we can calculate these MNist datasets for the further classification in this computer vision section. Yes, thank you very much for your time.